Now I'd like to show you how to do term-by-term evaluation of numerical expressions. These are the same expressions that you usually do by order of operations. In the second box here, I have written the order of operations. The groupings are always first, whether they're parentheses or whether they're absolute values, okay, with something to do in them. Operations are done with the exponents from left to right, then multiply or divide from left to right, and finally addition. And since subtractions are turned to addition, it's just addition now. Before we get started, I want to remind you that when something is written like -3 to the second power, the negative is as though it's multiplying by -1. So the second power is done first. It's an exponent, and then you take the negative. Okay? The negative, attaching the negative is treated like a multiplication because it has the same effect as a multiplication on the number. So the answer there would be 9 and the negative of 9. So it's -9. To have it mean that a -3 is squared, it has to be written in a parentheses so that the whole value in the parentheses is being squared. And that means -3 times -3, which is +9. All right? Okay, now I'm going to just show you several examples. And the advantage here is you have less writing. And there's another advantage. It's helping you to recognize terms in an expression. And terms are very important. They play a big role later on in algebra. All right, the first thing you do in order is to set, maybe I should mention first that notice that the last thing ever done in order of operations is addition. And since it's going to be done last, it separates the problem into parts. And so the first thing we want to do is kind of make a vertical line under any add or subtract in the problem that are not inside of parentheses. And that breaks the problem into parts called terms. This problem has two terms. The first negative is actually part of the -1. Okay? And so on the left we have a grouping 4 minus 11, or 4 and -11, which is -7. We do the grouping first, times -1, and we get a +7, and we just bring down the +6, and we get 13. I'm not going to do only easy ones. So, all right, let's go and do the second problem. We put a dotted line under the plus, and it breaks it into two parts. There's nothing to do in the first part, so we just do the second part. We do the exponent on the 4 first. You can go over to the side and do that if you wish. 4 times 4 is 16, times 4 is 64. Bring the 64 back there, times 3. That's 192. And there's a plus between them. And so we have -12 plus 192. It's 192 on the positive side, 12 on the negative side, and the answer is a +180. Okay, here are two more problems. Now first I look to see addition or subtraction that aren't in parentheses or groupings. And there's one right here. Put a little dot, and it breaks the problem into two parts. I'm going to do the second part first because it's so easy. Remember to take the sign, the subtraction as the sign of the 2. -2 times -8 is a +16. All right, I'm done with that part. Then I can go to the other part. Well, the other part has an absolute value, and absolute values are kind of like parentheses. You must calculate them and get the number value before you do anything else. It's like a grouping, but it's even more complicated than a grouping. The absolute value of negative 5 is 5. And so we have 5 times negative 4, and that's negative 20. And then our final answer, negative 20 plus 16, is negative 4. All right, let's work with the second problem here. It has a subtraction right here that is not in parentheses or grouping, and an addition. So it's got several parts here, and we can see this absolute value in the first part. And you can do any part you want first. That's the nice thing about this method. And you don't have to rewrite everything every time. You just get one part finished, the next part finished, and then you're on your way. Okay, well, the plus 11's easy. And remember, the negative is attached after you square the 4. So square 4, you get 16, and that has a minus in front of it. So that's all there is for those two parts. The first part's a little harder. We have to work inside the absolute value symbol and see what we get there using order of operations. And that's kind of like a mini group there. But we're going to do the exponent first. 2 cubed is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So that's 8 and minus 10. So we have the absolute value of 8 minus 10, which is the absolute value of 8 and negative 10, which is the absolute value of negative 2. I'll refresh your memory over there. That's 10 negative versus 8 positive. There's more on the negative, so it's negative 2. And the absolute value of a negative 2 is a positive 2. Okay, so we're down to the last step, which is only addition. And on this step, we have a positive 2, a negative 16, and a positive 11. So we have 13 positive versus 16 negative, so the answer is negative 3. So that's negative 3. I'm sorry I ran off the side there, but maybe I'll move it back over here for you to see. Just a second. My scratch work ran off the page. Okay, here's your, all right. And that's that problem. The main thing there is you want to make sure you get that absolute value completely down to where it's a number without an absolute value before you do anything else, okay, to it. Okay, let's look at the last two problems. Okay, both of these have something in common. When I look at this first one, I see a subtraction right there and a subtraction right there, but they're inside grouping symbols. So this one is all one term. And so is this one, because the fraction bar is a grouping symbol. It groups all of the numerator together and then all the denominator together. So we're out of luck there. But the same thing that you did with several terms, I can treat this bracket, which starts right here and ends right here, as a grouping symbol, as a separate problem almost, and leave the negative 2 where it is, and just work inside. And I'm going to put just a little dotted line here, and that 8 is in front of it, and inside I've got a grouping, 9 minus 14, that's 9 and negative 14, which is negative 5, and that negative 5 has to be squared, which is negative 5 times negative 5, which is a positive 25. And in front of it is a negative 3, and that ends up being negative 75, and an 8 there. So you kind of can work on that tail end, everything after this minus right here, including the negative minus, but and leave that 8 alone for a while, and then come back, and you've got the 8 minus 75 in the grouping. Well, that's a negative 75 and a positive 8. So, of course, the answer is negative. It's a negative 67. In the grouping symbol, and you've still got that 2 there, which has been there all along, right? The negative 2, sorry. And so the final answer is going to be a positive 67 times 2, 14, carry 1, 134. So the final answer is 134. Now this one over here, we could sort of group in the numerator, just separate by addition these two parts. Negative 5 times negative 4 is negative 20, which is a positive 20. And negative 2 times 6 is a negative 12. All right, so we have 20 and negative 12, which is 8. So we're ending up with 8 over. Now you have to get this all the way down to a number value. Okay, so we're inside the absolute value symbol. We have 3 squared, which is 3 times 3, or 9, minus 7. And keep going till it's a single number in there. 9 minus 7 is 2. And then you can take its absolute value and get the number 2. So that's what goes right here. And so on these two problems, we didn't really see where we could separate it into terms. We didn't save any work, but in many problems, we will save work by separating it into terms. And I meant to tell you earlier, that is what calculators do. They're programmed by engineers to be as efficient as possible. And they work up to the first plus or minus, get that value, then work between that plus or minus and the next, get that value, and then combine them. And so they do one term at a time and gradually build up to the end of the problem. A little bit different than what we're doing, but they don't work with the whole problem all at once.